Hello everyone, and welcome back to the Fluctus Channel. In military aviation, the F-22 Raptor is known as the undisputed king of the sky, in theory anyway. With its latest upgrades, it is even more lethal. But just wait until you see the crazy technique the US found to start up this $350 million stealth jet. In 2025, the F-22 Raptor will be 20 years old. Despite its age, it's still the best in the sky, with a mission-capable rate of 70% and a sortie rate of 3.2 per day, meaning it can generate 3.2 flights daily. F-22 Raptor has a maximum speed of Mach 2.25, a range of 1,839 miles, and enhanced stealth capabilities. It is powered by two Pratt & Whitney F119 PW100 engines, which allow for supercruise. At startup, the F-22's Auxiliary Power Generation System, APGS, powers the aircraft systems. The APGS is a self-contained unit that generates electricity from a tiny gas turbine engine, allowing the F-22 to activate its main engines without external power. This mechanism allows the F-22 to function independently, even in distant or austere locations. As the APU exhaust is positioned on the starboard side of the F-22, just aft from the cockpit. During weapons loading, weapons loaders avoid the APU exhaust area because hot gases expelled from the exhaust can harm the weapons. To reduce this risk, the F-22's weapons loading technique requires precise positioning of the weapons loader and the weapons themselves to avoid the APU exhaust area. Furthermore, the F-22's APU is designed to be turned off during weapon loading to avoid accidental startup or exhaust gas emission. This provides a safe and controlled atmosphere for the weapons loaders to complete their tasks. Unlike the F-22, which keeps all its weapons tucked inside, the F-35A Lightning II can carry armaments both internally and externally. Its wings and fuselage feature specially designed pylons and launchers, letting it handle larger or heavier weapons that won't fit in the internal bays. This flexibility boosts payload and mission capability, especially when stealth isn't the priority. When stealth is critical, all weapons are loaded into internal weapon bays. The F-35's internal weapons loading method entails placing weapons in the aircraft's two internal bays, one on each side of the fuselage. The bays are meant to hold a range of weaponry, such as bombs, missiles, and rockets. The loading method includes opening the bay doors, placing the weapon on a dedicated loader, and sliding it into the bay. The weapon is then locked in place with mechanical and electrical connections. The F-35's powerful ALIS Autonomic Logistics Information System, computer system, directs the loading procedure, ensuring that the correct armament is loaded into the appropriate bay. A team of 2 or 3 personnel usually completes the entire operation. In comparison to the F-22 and the F-35, the B-52 has a massive radar cross-section, but it does not need to defend itself. On a B-52 Stratofortress, a team of technicians and airmen work together to load bombs, missiles, and other weaponry. The process begins with a comprehensive assessment of the aircraft's armament bays and pylons to verify they are free of debris and operational. The weapons are then delivered to the aircraft on specialized trailers and hauled into position using hydraulic lifts and winches, including munitions handling units. The specialists next secure the weapons to the aircraft via mechanical lugs and mill standard 1760 cable. B-52 weapon loading and drop operations are complex procedures meant to ensure precision and safety. The aircraft has 2 internal bomb bays, each with rotary launchers and standard bomb racks. To preserve balance in flying performance, ground operators load armaments with high-lift trucks and hoists, while closely complying with weight distribution specifications. Each weapon communicates electronically with the aircraft's fire control system. During a mission, the bombardier or weapons systems officer, WSO, employs modern radar and targeting systems to direct the aircraft to its goal. When the bomb bay doors reach the designated drop zone, they automatically open hydraulically. The rotating launchers then revolve, positioning the munitions for discharge. Weapons are deployed in a certain order chosen by the onboard computer to maximize impact on the target. Following the drop, the aircraft systems do a verification check to ensure effective deployment, and the aircraft either continues its mission or returns to base. Another type of aircraft has a completely different role in weapons loading procedure. Loading an AC-130 gunship requires a rigorous process to equip its flexible weaponry for a wide range of mission types. Ground crews utilize specialized equipment to load ammunition onto external hardpoints and manually pack other ammunition in storage racks in the battle compartment. The AC-130 carries a variety of weaponry, including 1 05mm howitzers, 30mm autocannons, and precision-guided missiles. Ammunition for the various weapon systems is stowed in special lockers and racks. These are designed to balance the center of gravity of the aircraft. Especially heavy 105mm howitzer shells need to be stowed correctly. When loading is done, the most senior special mission aviator reports to the pilot. Next, the aircraft initiates its startup procedure. To start an AC-130 with a ground power unit, it is first attached to the aircraft, and the electrical system is activated. The GPU powers the starter motor, which fires up the first engine. Once the first engine starts, the aircraft's generators take over, and the GPU is removed. This method is done with the remaining 3 engines. Following the activation of all 4 engines, the generators power the electrical system, and the engines are throttled up for taxiing and takeoff. When there is no GPU, the MC-130H uses its onboard auxiliary power unit, APU, to start its engines. Once the APU is operational and supplying electricity, the crew begins the startup sequence for the first engine, which is typically an inboard engine. The starter motor turns on, spooling up the engine until it reaches the desired RPM. The fuel is then supplied for ignition. This process is repeated for the remaining engines, with power supplied by the APU. B-52s usually take about an hour to start all 8 of their engines, but they have a neat trick to make it all much faster. On a B-52, the cartridge start procedure involves igniting a high-pressure gas charge into the engine's starter motor via a small detonation. The cartridge is inserted into the engine's starter motor, and when activated, it produces a burst of gas, which turns the engine. This approach is employed on the B-52 because it provides a dependable and self-contained method of starting the engines, particularly in remote or emergency situations where external power sources may be unavailable and speed is critical. The B-52 Stratofortress is powered by TF33P3/103 turbofan engines with a high bypass ratio. Each engine generates 17,000 pounds of thrust and contains a 14-stage compressor, a 2-stage turbine, and a 4-stage fan. Although these engines are dependable and efficient, they are becoming obsolete, with limited spare parts availability and rising maintenance costs. Their low bypass ratio and absence of new technologies, such as high-pressure compressors and sophisticated materials, render them less efficient than modern engines. A new engine is in the works, though. The Rolls-Royce F-130 is a new turbofan engine being evaluated for the B-52 Stratofortress. It provides considerable improvements over the TF33P3/103 engines, such as a 20% increase in thrust, a 20% reduction in fuel consumption, and a 50% reduction in maintenance expenses. The new engine is projected to increase the B-52's service life and overall performance, making it an important update for the aging fleet. Ground power units are used to start almost all U.S. Air Force aircraft. In times of haste, the B-52 uses exploding cartridges to start its engines. And most aircraft have auxiliary power units, APUs. APUs are just less efficient, and prolonged use can drastically shorten an aircraft's lifespan. When you see an F-22 starting with its APU, it becomes apparent that compressed air from GPUs is much more effective. What truly defines modern military aviation is not just speed, stealth, or firepower, but the intricate systems and procedures that make these aircraft mission-ready. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.